Let's review what we saw with Grid Search CV. Grid Search CV is going to accept an estimator, and the other parameter you have to pass it is a dictionary that tells it what hyperparameters you want to tune and what are the values for those hyperparameters to investigate. So it's going to take that dictionary, construct a grid, and search through all those possible combinations. When you use grid search, what returns to you back, you construct a grid search object, which itself is an estimator. That's an estimator with a fit and predict method. When you invoke the fit method, it's going to undergo this k-folds cross-validation strategy we discussed before. And then every time you call predict, it's going to use the best model to make a prediction. But the problem with Grid Search CV, or one of the limitations it has, is you can only use it to tune one model at a time. So what if there are two models we want to investigate, two models we want to see which one is better? So in this example here, let's compare our decision tree model. We're going to tune the decision tree model and compare it against a tuned k-nearest neighbor model. We'll have a whole set of lectures regarding k-nearest neighbors. But the way it works, if you want to make a prediction with a k-nearest neighbors model, it's going to put that point you want to make a prediction on into their feature space with all your training data and look for its k-nearest neighbors. And then from the k-nearest neighbors is going to use those neighbors to make a prediction. So let's define our two models here. We're going to construct objects for our model. So we have the decision tree regressor and the k-nearest neighbors regressor. And let's put those models in a dictionary. So we have those models in a dictionary. And let's create a dictionary with all the hyperparameters that we want to tune for our model. So we have one key for this dictionary. Is the value for that is another dictionary, which says, okay, let's tune the min sample split given this iterable here. So 10 to 100 of spacings of 10. And let's also tune the max depth, 1 to 14. But for our k-nearest neighbors, it has its own set of hyperparameters with different names. And the key hyperparameter for k-nearest neighbors is the number of neighbors to include when you make a prediction. So here we're going to investigate values from 10 all the way to 90 of spacing of 10. Remember, Python's going to use inclusive-exclusive convention when you use a function like range. And this parameter here is a spacing of 10. So 10 all the way to 100, not including 100, of spacing of 10. Now let's go ahead and construct a for loop. So we have this dictionary that we're going to store our values. So we have our for loop. Let's iterate through our estimators. Create the grid search object by passing the estimator we're going to investigate. The hyperparameters for that corresponding model will have 5 folds in our cross-validation scheme. Let's go ahead and run 2 jobs in parallel. Let's use a negative mean squared error as our scoring metric. Let's go ahead and invoke the fit method. And there's a best score attribute for our train grid search object, which will tell us the best score. Go ahead and run that. See the results. This might take a little while. In this case, I didn't set verbose equal to 1, but you can go ahead and set that keyword argument for the grid search CV and verbose equal to 1. It'll tell you how to print out. It'll print out what's going on in the training process. So let's just go ahead and show you that right there. So it's telling you, okay, I'm doing these, I'm doing 5 folds, this many candidates. It's a great way to understand, to see what's going on, and such that you can get some idea, okay, it's actually running. You don't want to run something, nothing is really going on, and then you waste all this time. But this is a nice way you can get some update of what's going on. Okay. So it looks here that our best model was our k-nearest neighbor, slightly better than our tree model. So a question we pose to you here is, even though the k-nearest neighbor performed better than the decision tree, why might you want to pick the decision tree model? What might be your considerations why you should go ahead and pick using the decision tree model as opposed to something like k-nearest neighbors? While supervised machine learning focuses on making predictions, sometimes that isn't your only priority. We saw that with decision trees, you can easily visualize the model, understand how it's making predictions, get a better feel of what's going on. So because of that, perhaps you're willing to sacrifice some model performance for that higher explicability. There are other things you should consider of why it might make sense you should use a model that performs slightly worse. It depends on what your priorities are. Let's say some of your priorities are a model that is fast to make predictions, then you want to use a model that has a faster prediction time. Of course, you have to consider, are you worth sacrificing some model's performance for a faster training time or faster prediction time?